All right, here's part 2 of the study guide. I'll go through the rest of the problems now with you guys. All right, so we begin the section where you're given just some information about the triangle. You can draw your own triangle if it helps you. Make sure that you kind of draw it accurately. So for example, we've got a 76-degree angle here. That's probably going to go like down in one of these corners here. So I put it as this lower left corner, 76. Since I have also side B, that's going to go across from angle B. And then side A, it doesn't really matter where you put it. It does say that it's 18, so I want it to be shorter than the side that I just labeled as 20. So I'm going to put it over here, which means that this is going to be A, and this is going to be C. Okay, so this is, right off the bat, one of those where it's side, side, angle. So it's possible that it's an ambiguous case, but to check it, we check to see if the side across from the given angle is longer than the side, the other side that's given, and it is. So I know that on your note sheet it says A has to be greater than B, but they are reversed in this particular problem, and so we're looking to see if the side across from the given angle is greater than the other given side, and it is. And so that makes it one triangle. We don't have to worry about finding a second triangle or no triangle. Okay? All right, so let's set it up. We want to see what we have. So let's go A, B, and C. And side A, side B, and side C. We've decided to call A 18. Well, they called A 18, B 20, and angle B 76 degrees. Okay, so angle, angle, and a side. So we have a pair. We can use the law of sines, right? We're good. And we can solve for angle A because we have side A. So we're going to say the sine of angle A over 18 equals the sine of 76 over 20. And it doesn't matter whether you put the sides on top and the angles on the bottom or vice versa. It still works out the same. Cross multiply, and angle A turns out to be 60.8 degrees. All right, once you have found angle A, finding angle C is just a matter of subtracting. So you subtract and you get 43.2 degrees. And I mean subtract from 180 because you already know two of the triangle's angles. And then you do need to set up one more law of sines to solve for side C. So you can say C over the sine of the 43.2 that you just figured out equals 18. No, I'm sorry, not 18. Let's go with the given one. Let's go with the 20 over the sine of 76. And when you cross multiply and solve for side C on that one, you're going to get 14.11. Back to angle A. When you were solving for angle A, you should have used inverse sine to solve for that, just in case you forgot, or you didn't know how I got that. Okay, so we have done it. We have solved for all the missing parts of the triangle. All right, number 11. Let's try doing this one without drawing it. Let's see what we've got. We've got A is 48 degrees. We have B is 72 degrees. Ooh, you know that's going to be easy to find the missing angle then. I'm going to do it right now. I'm going to subtract and get 60 degrees for the missing one. All right, now which sides have been given to us? The sides that have been given to us is only one of the sides. It's side B, so we're missing two of the sides. So this is an angle, angle, side. Angle, angle, side. So there's no ambiguity here. We just need to set up the law of sines and solve for the missing side. So the first side that I solved for, and it actually only asks us to find side C. I just noticed that. In the last problem, we only had to find side C as well, but I had to find all the other ones just to get to that. For this one, I was ready and prepared to solve for all of the missing parts. But really, it only asks us for C, so we don't have to worry about A. We can just go ahead and solve for C. So we're going to say 22 over the sine of 72, that's the given information, equals the missing side C over the sine of 60 degrees. And let's see, That turns out to be, when you cross multiply, 20.03. And that's the only one they actually want you to find. On the test, I ask you to find all the missing ones. All right, number 12. All right, this time we're given angle C is 49 degrees. We don't know B or A, but we do know side A and side B. And we're only asked to find angle B. All right, this one looks trickier to me because we don't have a pair. So we don't have a matching A, or B, or C. So we can't use the law of sines. But the law of cosines, although it's more complicated, is actually pretty nice to use. We can solve for the missing side as long as we have the angle across from it and the other two sides. So we're going to go for this first, and then we'll eventually find angle B, but we're going to have to go for C first. So just approach it as if you're going to find everything, and then you'll eventually find what it is that I'm asking for in these questions. All right, so for this one, we're going to say side C squared equals side A squared plus side B squared minus 2 times side A times side B times the cosine of angle C. And remember, this always has to match this. So the angle has to match the side that you're trying to solve for. All right, so when you plug all that into your calculator and then take the square root of it, you get that side C is 18.1, which would be great if that's what they wanted you to find, but they want you to find angle B. So at this point, we now have enough information because we have a pair that we can set up the law of sines and solve for the missing angle. So that's where I would go from here. So for this one, I'm going to set up the sine of 49 degrees over that 18.1 that I just solved for equals the sine of angle B over 24. I'm going to cross multiply and inverse sine it. And when I do that, I should get, I actually have written in my notes that you have to find angle A first, the smaller of the two. Let me see if angle B leads to an error. Let me double check. 24 sine of 49 divided by 18.1. Yep, that's going to give me an error. So you need to go for the smallest one first, or your calculator thinks you're crazy. So if you go for the smaller of the two, which would be angle A, because it has a smaller side across from it, then you would set it up 49 degrees. I shouldn't have forgotten that. Equals the sine of A. Sine of 49 over 18.1 equals sine of A over 15. Then when you try to solve it, you're going to get angle A equals 38.7 degrees. 38.7. Then you can subtract and find angle B, 92.3. All right, so I guess the rule is when you're using the law of sines, go for the smallest angle first. When you're using the law of cosines, go for the largest angle first. All right, number 13. Number 13 gives us a triangle where angle A is 68. Ooh, this is it. This is it. This is side-side angle, and we have an acute angle across from a side that's shorter than the other side given. So this is the ambiguous case. All right, I'm going to draw this one because it helps me with the ambiguous case if I have a drawing. So the first triangle we're going to solve for, we're going to put A down here in the corner. We're going to put the 12.9 over here, and we're going to put 13.8 here. Now, it may not look like it the way I've drawn it, but that 12.9, because it's shorter than 13.8, can go in two locations. It can also go there. But we're going to solve for this first triangle, and then we'll worry about the second one. So if you don't notice it, you just go just like normal, and you say, okay, I do not have law of sines, or law of cosines situation. I have the law of sines. So I'm going to solve for the missing angle, which would be over here. Okay, and you're going to call that angle B because it's across from the one that you've labeled as side B, and that makes this C. So we're going to solve for that first. We're also supposed to check to see if it's even possible to have a triangle here. So because A is greater than B, that's great, but now we need to see if it's less than h. So we do need to double check and find the height. So the height is found by looking at this little right triangle right here. So we're going to say the sine of 68 degrees equals the height over 13.8. And it turns out that the height for that one, that triangle, is 12.79. So it's long enough. The height is barely longer than the 12.9. So the 12.9 is actually probably going to sit down like this. And then it's going to also be able to sit inside. And I'll show you that in just a minute. So let's put the 12.9 right there, because it's barely longer than the height. 12.79 is the height. 12.9, a little bit longer than that, is that side A there. Okay, so we're going to set it up and we're going to solve for the missing part. So we've got angle A given to us as 68. We have side A is 12.9. We don't know angle B. We don't know angle C. But we do know side B is 13.8. And side C we don't know. So we go first for angle B right here. So in this triangle, we're going to have the ones I've highlighted in blue there. So we're going to set up the law of sines. 12.9 over the sine of 68 degrees equals 13.8 times the sine of B. We're going to cross multiply, inverse sine it, and we're going to get angle B is 82.7 degrees. Okay, we subtract from 180 the two angles that we now know to get the third angle, angle C, 29.3. And then we set up the law of sines one more time with 12.9 over the sine of 68. But this time we are trying to find side C, and we use the 29.3 that we derived from the earlier calculation. So we get that side C turns out to be 6.8. Okay, and if you get that far on the test, you will get 8 out of the 10 points on that question. But this is the ambiguous case question, where there is actually another possible triangle. The other possible triangle I'm going to show you in green here, or maybe I'll do it in yellow. The other possible triangle has the same A, B, and A, angle A, side A, but the 12.9 is laying on the inside. So we move that 12.9 in here. Now we just calculated angle B here, but now angle B is going to move over to there. So the new angle B is going to be 180 minus 82.7 degrees. And so the new angle B is going to be 97.3 degrees. That's for the one I've marked in yellow. Okay, which makes the new angle C, which is now up here on top, but it's a smaller angle. It's going to be 180 minus angle A and angle B. So this one turns out to be 14.7 degrees. So this is for the second triangle, the yellow triangle. And so the only thing left to solve for is side C. So you have to do one more law of sines, going back to the original 68 degrees and the 12.9. And this time you use the 14.7 degrees, that little tiny angle in the top corner, and you solve for side C. And this time you get a short side C, 3.5. So the second triangle is here in yellow. And that's going to be worth 2 points on the test. So if you don't catch it, it's okay. Solve for the first one, and you'll be none the worse off if you don't realize the second one. Okay, number 14. We've changed the letters on you here. Don't let that freak you out. But a 100-degree angle to start with is a pretty big angle, so I would put that down here. That's 100 degrees. Let me change colors here. And then we have side P being 15, and then the other side that we've been given to us is 14. This is the side-side angle situation, and it's the situation where side B, well, I should say it this way, side A is less than B, and it leads to no triangle. They've called it R, P, and R, but it's the same concept. So this one is an impossible triangle. There is no way that you can get those to make a triangle. All right, moving on. We've got a few more to do here. All right, number 15 is, ooh, I like this one. This is a side, side, side. And when it's side, 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 you can find any of the three angles, but it's always wise to start with the largest, and that's the one they want us to find. So this is going to be one calculation. We're going to use the version of the law of sines that says cosine of b equals, let me write this correctly. The way that I gave it to you guys in class is b squared minus a squared minus c squared divided by negative 2ac. I noticed that on my answer key, I used this version of the formula. I said cosine of b equals c squared minus a squared minus b squared over 2ac. The difference is where that negative is. I wrote it as just a rearranged version of the original one that I gave you. And then last year, I must have taught it where that negative gets moved up to the top and distributed to the A's, the B's, and the C's. So it changes the sign. Wait a second. It would be c squared plus a squared plus b squared. Yeah, there we go. If you distribute that negative, it's going to change the sign on everything. And so I'm looking to see what I have here. I have, on the answer key that I'm looking at, which was my work from last year, I did 13 squared, so that would be a squared. I have the minus on the 24. So minus b squared. Yeah, that would be right. Because if I change the sign on that, yeah, let me do that. The formula made more sense to me this way because I just rearranged the other one in my head. But I must have taught it last year where I moved the negative up to the top. So it was not negative in the denominator. And that changed A and C to positives and B to being negative. Either way, you're going to get the same answer, and your calculator is going to do all the work. So type in the A's, B's, and C's in either one of these formulas. The way I have it on the answer key is this one right here. So I have 13 squared plus 19 squared. Those are the two sides that are not opposite the angle that you're looking for. And then I subtracted the side across from the angle that you are looking for. And then I put the other two in the bottom without a negative because the negative got moved up to the top. Regardless, type all that into your calculator. Make sure you put parentheses around the numerator and the denominator, and then inverse cosine it. And you're going to find out that angle B is 95.3 degrees. And that's the only one you have to find on that question. Okay, two more. All right, this time we have B. This is possibly an ambiguous one because it's side-side angle. So let's check it out. It looks like if we put B down here, 55 degrees, and we make side B 11, and side A is 13, this time A is going to be here and B is going to be there, so we reversed it from the last one. Yeah, sure enough, we have the situation where the side is shorter than the other given side, but we need to check the height. So let's check the height. Sine of 55 degrees equals the height over 13, which means the height is equal to 10.65. Darn it, again, it's just barely longer than the height. So that means two triangles, guys. It means it's either this triangle, the purple one, or it's this triangle, the yellow one. That 11 is long enough to reach down in two ways. If it was longer than 13, we'd only get one triangle, but we're going to get two. All right, I promise I'm not going to give you two of these on the test, only one. So first thing we need to do is solve for angle A. We know side A, we know angle B, we don't know angle C or side C. So we're going to set up the law of sines and solve for angle A. That's the only thing we can do. So sine of 55 degrees over 11 equals the sine of angle A over 13. Cross multiply, inverse sine, and get 75.5 degrees. Okay. In your formulas, for this example, they always make the given angle angle A. So they're going to basically reverse A and B in the ambiguous case note sheet. But that's okay. You can just leave them the way they are. Okay, so angle C we now get by subtracting from 180. So we get 49.5 for this one. And then we set up the law of sines again. Sine of 55 degrees over 11, that's our given. But this time we have a new angle, sine of 49.5. We just figured that out over side C. And when you cross multiply and solve for C, you're going to get 10.2. All right, all dandy. That's the purple triangle, okay? And you're good. You get 8 out of 10 points on that question on the quiz. But if you're really sharp and you notice that there's another triangle, the yellow one, then you're going to leave the given information the same. That's given. You also knew that side A was 13, but you're going to come up with a secondary A because now A is going to move over to here. And so A is going to be 180 minus whatever you got for angle A in the first triangle. So 180 minus 75.5 gives me 104.5. So subtraction to find that one. Now a new subtraction to figure out C, subtracting the two angles above it, gives us a little tiny C, 20.5 degrees. And the only extra sign or law of sines that you have to do is for side C. So one more time, you're going to use that given information. You're going to go 11 over sine of 55, and then you're going to do C over the sine of 20.5. And you're going to solve for side C, and it's going to be short this time. Turns out to be only 4.7, because that's inside here, right? If you look at my triangle, that's that little side C inside the yellow triangle. All right, last but not least, we have an obtuse angle A, 100 degrees. We have the side across from it is 20. And luckily the other side is shorter. Doesn't matter where you put it. If I put B there and C there, then this becomes my 15. Okay. It asked me to find side C, the third side, which is over here. The one that I don't have. Can I do that? I don't think I can. It helps me if I write it down this way. Angle A is 100. Whoops. That's not what I wanted to write. A is 100 and side A is 20. B, I don't know. C, I don't know. B is 15 and side C, I also don't know. So as much as I'd like to find side C right away, I can't because I don't know angle C. So I'm going to have to go for angle B first. So I'm going to use the law of sines because I have a pair, and I'm going to say 20 over the sine of 100 equals 15 over the sine of B. Solving for angle B using inverse sine, I get 47.6 degrees. Now I can find angle C by subtracting the other two from 180 and get 32.4 degrees. Now I can do one more law of sines using the same 20 and 100 that were given for A, but this time solving for side C using the 32.4 degrees that's across from side C. Cross multiply, you don't need to inverse sine this one because you're not looking for an angle, you're looking for a side, and you get C is 10.9. All right, so the test is 14 questions. You get to use a partner, and I promise there's only one that has two different triangles. So I think you'll be fine. The bearings problems are less complicated than the ones on the study guide, and you get to use your notes. So take some good notes. You do have to turn in your study guide. You don't get to use your study guide, but you can write any of these example problems in your notes if you're willing to take the time to do that. I wish you all the best of luck, and I will see you next week.